Happy New Year, everybody. I hope it's not too late to say that, but welcome to our January 2023 Akka.net community stand-up. So both myself and Gregorius are here live today, talking a bit about a lot of the work that's going on with Akka.net and also a couple of other adjacent projects like Phobos. And we're also going to share a very exciting show and tell from our friends at Priva. Now, the Priva folks are not here with us live. We actually went ahead and pre-recorded our presentation with them a few weeks ago, so they may not be able to answer any live questions, but I promise if you post them in Discord or on the Akka.net YouTube comments, they'll definitely go ahead and answer. Gregorius, how are you doing today?
Oh, pretty good.
Good.
Yeah.
Well, we should go ahead and walk through some of our recent Akka.net releases because there have been a lot of them since our December meetup. Gregorius and I did not have a very restful holiday season. We were frantically trying to ship lots of different parts of the Akka.net 1.5 roadmap. So why don't we go ahead and start with probably the biggest release of all of that, which is Akka.Hosting 1.0. So Gregorius, I'm going to go ahead and pull up the release notes. Why don't you take us through sort of the in broad strokes what it is we did between let's say the beta versions and 1.0.
Yeah, there has been a lot of changes in the public API, but we promise that since we released the RTM now, that all of the public API will now be frozen. So it is a stable code now. You can use it and be confident that we will honor our backward compatibility promise to you. And the biggest change, or well, one of the cool change, I think it's the coolest change, is that you can actually convert configuration directly to HOCON. You can write your configuration in JSON or even from the environment variables, and it will be injected as a HOCON inside your application. And then we did a lot of things that makes all of the hosting plugins basically standardized. Like all of them now take option classes that are POCO, and you can just use iConfiguration.get or .bind and pull your configuration from basically anywhere that iConfiguration supports.
Yeah, and that was kind of part of one of our sort of milestones we added to Akka.Hosting kind of late in the development process. Was we started with some of the earlier versions of Akka.Hosting, like 0.4 and 0.5, using them as some of our sample applications and also some of our own projects internally. And we found ourselves constantly creating our own little POCO classes and then feeding and then mapping those into the types that Akka.Hosting used. And we said, you know what, it'd probably be better if we could just parse the built-in Akka.Hosting sections directly out of Microsoft.extensions.configuration and just cut that step out for end users entirely. So Gregorius designed it so all of the really common parts of Akka.Hosting, such as your Akka.remote configuration and cluster configuration, can all be parsed that way. There are some sections that can't really be parsed that way necessarily. Like if I recall correctly, cluster sharding is one of them, since that does require you to pass in like a C# class for certain things. But other than a handful of areas like that, most of the common parts of Akka.net can be fully mapped out of like app settings now. There's no need to write HOCON at all virtually anymore, unless you're doing something super custom right now, like using a custom dispatcher or something like that. So that's a pretty major accomplishment. And then on top of Akka.Hosting 1.0, we just shipped both of these actually. So I wrote this agenda on Monday, but it's already out of date. We've actually taken Akka.HealthCheck and Akka.Management out of beta as of today. In fact, I was just checking to see if the Akka.HealthCheck, because we actually published a NuGet right before we started. There it is. 1.0 just got published live 5 minutes ago. So Akka.HealthCheck, which ties into the Microsoft.extensions.healthcheck system, is now 1.0, and so is Akka.Management. So Gregorius, which one of these two do you want to start with?
Oh, let's start with Akka.Management.
Start with Akka.Management. Okay.
Hmm.
And we should also probably pull up the new web crawler sample while we're at it too.
Yep.
Yep. All right. Take us through it.
For Akka management, we did some API breaking changes, but as before, this is now stable. So uh, it is the public API is frozen, and there's not a lot of changes in Akka management, to be honest. But the only change that we made is that we changed all of the extension methods from accepting setup classes to accepting a POCO option class. Of course, you can still use the setup classes. Just use the add setup extension method from Akka.Hosting, which does practically the same thing as the old setup class.
But the option classes are lower ceremony and can be parsed from Hocon. That's their big advantage.
It's a POCO class.
Yep.
Exactly.
So this is all kind of part of the process of trying to help simplify Akka.net. Now, Akka.Management isn't something we've really given the light of day on so much because it's kind of it's a feature that's really useful if you're a heavy Akka.Cluster user. I believe the guys at Priva actually are using our Azure service discovery plugin, which is
Hmm.
part of Akka.Management. So they'll actually mention that in their presentation. They've been kind of an early adopter of some of these features. We will definitely be doing a YouTube video that's exclusively about Akka.Management. We'll probably also do one about Akka.HealthCheck, and we'll probably do another one on Akka.Hosting as well. But I think basically, if we don't get a show and tell speaker lined up in either February or March, we'll definitely go ahead and probably do our own presentation for one of those. So that's something we'll get into some more detail on. The biggest advantage of Akka.Management is it basically eliminates the need to have like Lighthouse inside your cluster. So there's no need for static seed nodes anymore. They can be discovered dynamically via your environment. And
Hmm.
Gregorius did a pretty thorough job of documenting all the different tools and options that are in here. You just need to go to Akka.Management and view the README. And this will go ahead and break down where all this information is. We do have, I'll talk about this when we get to the Akka.net 1.5 roadmap. We do have a project coming up designed to consolidate all of the kind of disparate documentation spread out across all of the other non-core Akka.net repositories and bring it all back into the Akka.net website. So that is something that we will be doing. But for the time being, it's all available locally inside these individual repos. I guess the next thing to take a look at is Akka.HealthCheck.
Hmm.
This was a big project that both you and actually, funnily enough, one of our speakers, Wessel from Priva, spent a lot of time and effort working on. Why don't you share a little bit of the background about this project and why developers might want to use it?
Well, originally, this is a very, very specific plugin that you use if you want to use like Kubernetes and liveness check and readiness check. But we managed to actually make it compatible with the new ASP.NET iHealthCheck interface, and and we have created an integration basically uh, using Akka.Hosting. You can basically inject the Akka Health Check into iHealth into ASP.NET iHealthCheck quite easily. Um, One of the major improvements that we have with Akka Health Check is that now you can have multi-providers. That originally you can only have one probe. Now you can actually add in uh, both the default and the cluster and the persistence probe providers all in a single into a single endpoint, and it will just run through all of them and make sure that everything is working inside your node, basically.
So the default probes we provide out of the box in Akka.HealthCheck basically provides some pretty simple and general functionality, but it's actually pretty accurate in terms of determining whether your service is ready or live. The difference between a liveness and readiness check, these are basically kind of like Kubernetes terminologies, but they're also broadly applicable even outside of that. A
Mhm.
readiness health check is the equivalent of a load balancer health check, where the process is running, but it may not be ready to accept traffic yet. That's what a readiness check is for. A liveness check basically indicates, is the process able to continue working? If a liveness check fails in Kubernetes, the process is automatically killed and restarted when that happens. So some of the probes that we have built in, for instance, the persistence probe, we called it a suicide probe. Basically, it goes, writes a message to whatever the default Akka.Persistence journal is. And if it's not able to, so basically it writes a message, then kills itself, then recreates itself. And if it's not able to recover the message that it previously persisted, we I think we I think we have a tolerance for how long we're able to kind of do that. I don't remember exactly how that's specified anymore. But long story short, if the database that Akka.Persistence is talking to becomes unavailable, that probe will fail. That's what that's designed to do. Then for
Mhm.
Akka.Cluster, I think we just checked for the liveness probe there. I think we just checked to see if the cluster component is even running. Is that right, Gregorius?
Uh, for I think it's for liveness. We actually check if to see if there's actually anybody in the cluster. If
Gotcha.
there's
If
no
we're even
one in
in
the
a cluster.
cluster,
Got it.
yeah. If there's no one in the cluster, then we return not healthy.
Gotcha. Okay.
Yeah.
Um, well, basically, these are kind of designed to help tell you, like, is your system going to be able to function or not? And it integrates with the health check service that's built into Microsoft.extensions.healthchecks. So that's all kind of a new functionality. And this is all, by the way, piggybacking off of Akka.Hosting in a major way. So
Hmm.
Akka.Hosting kind of is what made this feasible to integrate with ASP.NET in a way that would have been very cantankerous had we tried to do it before. Um, Next, we actually have an Akka.NET release 1.4.48. Let me pull this up. This is a relatively small release we did at the beginning of this year. We basically made the future actor ref. This is the component that powers Ask under the covers. We made that unsealed. I used this to go ahead and inject some more accurate tracing inside Phobos. Is kind of why I did that. The other thing that we did was we moved the channel source and the channel sync out from Alpaca and into the main project. So we're going to deprecate the Alpaca package they used to ship with. Um, we are using iAsync enumerable and Akka Streams integration very heavily in one of our projects we're going to announce soon. And so one of our other contributors, Andrew, also had a need for this. So he went ahead and migrated those stages into the core Akka.NET project. So this is a relatively small update that probably doesn't affect you guys very much. Although if you're a Phobos user, you'll end up wanting to upgrade to this. Next, Phobos 2.1. Now, unfortunately, I haven't actually had a chance to get the Phobos website up to date because Windows Azure Pipelines is missing a dependency I need in order to do .NET 4.61 compilation because our test suite targets that, unfortunately. But just to kind of cover what Phobos 2.1 does real briefly, this is our first sort of major feature release in about a year on Phobos. It includes an enormous number of new features to keep track of Akka.Cluster sharding more accurately. In particular, we have the ability to track basically shard allocation and entity allocation data, and we have some built-in dashboards in Grafana and also we're working on one for Datadog right now that'll show you here's how many entities in this shard region are deployed across all the nodes in your cluster, or here's how many shards are deployed currently. And it's actually a very good way to kind of keep track of where loads distributed inside your system. On top of that, we took some of the actor telemetry we introduced in late November, and we made it much more accurate for keeping track of how many actors are alive at a given time in your system. We're using a gauge to do that now. So those are a couple of the big metrics changes. And then from a tracing standpoint, we made ask tracing much more accurate. That was why we unsealed the future actor ref. So it's much easier to figure out whether or not an ask operation completed successfully and how long it took and what the inputs and outputs were, where it came from, etc. On top of that, trace filtering just got a lot more powerful. We use that for filtering ask operations now as well. We automatically filter out all built-in Akka.Cluster sharding messages by default. And the most interesting feature that we built is a feature called trace compression for cluster sharding, which basically takes all of the different hops that your messages make going through the sharding system and flattens them down into a single line, basically. So instead of you getting 4 spans per message when you send a message to the sharding system, now you just get 2: the original parent span and then the recipient span. And we use some of the open telemetry activity processing pipelines to do that. And we'll go ahead and basically probably do a YouTube video. I'm actually in the process of scripting it out right now that walks through some of those changes. So that's all fun and good. So we've actually produced quite a lot so far at the beginning of this year, and we have a lot more yet to come. So we're going to go ahead and shift gears to talking about some of our upcoming Akka.net releases. I mentioned here Akka.TestKit.MSTest. I actually published this last night. We had a request from a fairly large enterprise user of Akka.net who is standardized on Microsoft's built-in testing solution, MS Test. We had a VS test kit for a long time, but it hasn't been updated since 2017. We had a member of our team go ahead and rewrite this to use MS Test, and we just published a version 1.448 of this last night. So that's available for users now. Now, the biggest thing we need to talk about is the Akka.net 1.5 and, for the first time ever, 1.6 roadmap split. I'm going to pull up the Akka.net 1.5 project real briefly so I can discuss this. Here we go. Total delivery. Okay. Let's see. We have a couple of smaller issues here. As you can see, we've actually got probably more in the done queue than we do in the other queues here. What is missing from the 1.5 roadmap right now are some of the major features that we haven't actually put. How do I put this? We haven't been able to commit a lot of time to developing them yet. The 2 big ones are Artery, the phased fuser, the phased materializer for Akka streams. Artery is the new Akka.remote transport. So Artery's been moved to 1.6. So is the new streams transport. And then on top of that, we're going to look at doing basically some improvements to the core of Akka.net, namely the dispatching system, as well as probably the way receive actors are implemented internally. We're moving all that to 1.6 because there's actually some pretty important features that are available in 1.5 right now that aren't in the hands of end users. A good example of that is the Akka.cluster sharding system is much more robust and much more performant in 1.5. We don't want to block that while we're sitting around prototyping these new transports and delivering it. So that's why we're breaking 1.5 up into 2 different releases. We're going to get the existing 1.5 release out now. This should be a much less significant release in terms of the impact it has on upgrading. It'll probably affect cluster sharding users the most. But some of the other big changes that are designed to help address Akka.net's performance over the network, its usability with respect to things like being able to run on AOT applications like Unity 3D. We're going to be addressing a lot of those as part of the Akka.net 1.6 effort. That's why we're kind of splitting this up into two chunks. So our time frame for getting Akka.net 1.5 shipped as is, I think the biggest thing on our plate right now is all of the link to DB changes, which is basically our replacement for the core Akka.persistence engine for most of the SQL-based plugins. Gregorius is pretty far down the road. He's been kind of running that project of getting a lot of that done, but we do need a bit more time, particularly on getting our strategy put together for how we're going to help users migrate off the old system onto the new one. We've got one, but we need a chance to battle test it. That's kind of the big thing we're waiting on. Other than that, we do have a couple of big features that still need to be delivered. I'm personally looking forward to getting structured logging finished. I've had a pull request for that. That's about 50% finished since October, but I haven't pushed it up yet. So that's one I'm looking forward to doing. And then on top of that, we're also going to be working on things like a pull methodology of reliable delivery. So instead of using an at least once delivery actor, you have something that's kind of more similar to like a Kafka partition that you can read from. So this is what we're working on. The time frame for 1.6, we're probably going to push that out to later this year. The projects I personally want to work on are things like Artery. And the reason being is that performance is a feature of Akka.net, and the way the current remoting system is designed, we know it's a bit of a bottleneck. And ultimately, what we need to address that is to change the flow, which is what Artery is about. One of the other changes we're considering making, per the suggestion of one of our users, Artery is basically, there's 2 modes of it in the original Scala project. There's Artery.tcp, which runs on top of Akka streams. And then there's Artery.udp, which runs on top of Aeron. Aeron is a high throughput UDP reliable transport system. We were considering, so Aeron is actually a viable option for the .NET project now. It was not for a long time because it had a dependency on the JVM media server being available, but now there's an embedded server in C that we can use. So we are considering doing that. It's also been suggested to me by one of our users that perhaps we should take a look at Microsoft's Quick implementation, which is what they're using to power HTTP 3. That is another sort of reliable UDP multiplexed transport system. That is currently in a bit of a beta status, and it's only available on .NET 7, I think, at the moment, but they're going to make it more widely available later this year. So that's something that we'll keep an eye on as well for our projects going forward. Okay. Oops, sorry about that. Gregorius, does my voice still sound robotic?
No, it's good now.
Yeah,
I
it
think
might have been
it was
some
just
packet loss on my end.
yeah.
Well, no worries. Well, are there any questions so far about any of our future or current releases? Doesn't look like it in chat. So in that case, without any further ado, I think we'll go ahead and kick off our show and tell, and let Wessel and Marco from Priva tell their story about how they use Akka.Cluster and Azure Container Apps to go ahead and manage large-scale horticulture for their customers. So we'll go ahead and dive into that right now. All right, so we're going to go ahead and introduce our show and tell speaker for January, which is Priva. And they're going to talk about how they use Akka.net to run large scale, I guess, horticultural automation and building automation using Akka.net. So I'm joined by Marco and Wessel from the Priva team. So Wessel and Marco, why don't you both introduce yourselves and lead us into your presentation?
Sure, Aaron. My name is Marco. I am an architect at Priva. That means I'm responsible for digital services. Wessel asked me to do an introduction about Priva, what we do, who we are. So that's why I'm here. And then I'm going to give the stage to Wessel to deep dive into to Akka.
Yes, I'm Wessel Kranenbach. I'm a tech lead at Priva at a team which is responsible for, amongst others, the real-time data platform. In there, we heavily use the actor model, and we just finished up building a new service which helps our customers. And for that, we used Akka.net. So we thought it would be nice to share a little bit about that, and also what we do with Akka.net also in the rest of Priva, and also share a little bit about the nice fit we saw for our use case.
Great, sounds good.
Sure, Wessel. Can
Yes.
you move the slide, please? So let me just give a little bit of an introduction about the Priva, who we are and what we do. Basically, what we do is we manage climate, and we do that for buildings and for greenhouses. We're a market leader for greenhouses, high-tech greenhouses in the world, world market leader, and market leader in the Netherlands for building automation. So what we try to do is create the best climate possible for people to thrive in and for crops to thrive in. Now, as a company, we really want to make a positive impact in the world around us. So we want to have a good influence for food safety, food security, and sustainability. So energy uses in building, in greenhouses, to kind of take care of the world. What we also do is combine the both, and that's what we call indoor growing, and that's basically growing crops inside of buildings. Like this, we can move food closer to the cities. That means that we have to move around less food to get food to the places where the people are, and like that, use less carbon fuels to actually move all this food around. So that's the core business of what we do. Wessel, can you move the slide? We're based in the Netherlands, but we have offices around the world. So we have locations in United States, South America, China, and Middle East. So we're doing our managing of climate around the world. We have around 500 employees. We have three markets, so horticulture, greenhouses, growing crops and plants. buildings, building automation. We create smart buildings, and we do indoor growing, which is the combination of the two. Now, Wessel, if you can move the slide. To be able to service these markets and to provide smart services for our customers, we of course have to have infrastructure and we have to have an architecture. And it kind of looks like the following picture. On top, for our customers, we have our services. These can be services for daily operation. These can be AI-based services for energy reduction, or these can be AI services for automatically growing the crops and having the best yield possible. We also have APIs, external APIs for partners who have AI-based services to control our buildings and to control our greenhouses. And to be able to do this, we created a platform in the cloud. And in this platform, we have different services. So we have a gateway management service for managing the gateways at our customers. The gateway provides a secure connection from on-premise towards the cloud. And it's also a platform to run local applications on. For data platform, which is storing a lot of data for use for analysis, for analytics, AI. We have metadata describing how our buildings and greenhouses look like, providing context so we can do smarter things with the information and combining all kinds of data. And we have a real-time platform, which communicates real-time information from on-premise, from our systems, towards all kinds of applications. So this can be applications for daily for daily use, showing things like a temperature in a room or a temperature in a greenhouse. And these are really real-time information because in a building, in a horti, or in a greenhouse, there are so many data points that it's impossible to send all the data all the time. So this is a POP-SAP system. This is the system that was already mentioned by Wessel. It's the system where Wessel and his team are working on. And this is the place where we started to use the actor model because we needed something that can deal with a lot of concurrency, a lot of consumers, a lot of publishers. There's a lot of real-time information going through here, which need to be sent to the right consumer. And that's why we basically use an actor model, because it's the best way to build a concurrent and scalable system. Then we have our gateway. Gateway is running on-premise. It's our connection to all kinds of devices that we have running on-premise. So we have all kinds of smart devices. We have water systems. We even have robots driving around through our greenhouses. And these are all connected to the gateway. So the gateway provides an abstraction layer for all kinds of devices to communicate towards our services in the cloud. Now on this gateway, we are also using an actor model because we have to deal there with a lot of state. For example, is a device online? Is it offline? We're also dealing there with a POP-SAP mechanism to get real-time information out of these systems. We cannot provide that data all the time because it's too much. So it's on a publish and subscribe method way. So we're dealing with state and concurrency, maybe even scalability, that we have to scale out to another gateway because the load is too high. And that's the other use for the actor model. So for these first versions, we used other actor models. So on the gateway, we started off with Orleans, for example. In the cloud, we started off with Service Fabric. But now for the new iteration of all our services, both in the cloud and on the gateway, we're standardizing on Akka.net. I think Wes was going to talk a little bit more about why we do this. So Wessel, can I transfer the word to you?
Yes, indeed. That was indeed the bridge also to look at the service we have been building right now. Because we are standardizing on Akka.net, we also used Akka.net for building that. And I will dive a little bit more into that, but I will first talk a little bit more about the service itself. So it gives a little bit about the context of the service which we were building, and then I will dive a little bit into why Akka.net was a good fit for that. Marco already told during showing the architecture of the cloud platform and the Priva landscape that we have a lot of devices which are there in the field, robots, water systems, and all kind of devices. And that we have gateways which are there on-premise at the customer side and which make the communication towards the Priva cloud. And as a result of that, this gateway is one of the crucial components in the connectivity to the cloud because it is the gateway. It's very obvious, of course. So we have connected that one to an IoT hub, but the data from that is shown in all the business applications. Marco already mentioned a few of them. I've noted a few of them also here. Operator, that day-to-day operations are being done. Notification center, there all the alerts and notifications where the customer need to act upon are handled and are being made visible for the customer. And then we have, for example, an installation and maintenance application where the customer can commission and do maintenance on his devices and gateways. But in all these applications, it makes sense that they only show the real values and the real data from the customer side when that gateway is online, when there is a connectivity. So we wanted to have a way to notify those applications and to determine whether or not those applications are, whether or not the gateway of that customer is online or offline, because there can be hundreds of reasons why a gateway can be offline. That can be due to a bad internet connection. That can be due to a power outage, or just name a few reasons. We wanted to detect that. And for that, we built and we created a vision for a system state service. This system state service should be capable of handling incoming data and based on the data, detect whether or not the system is online or offline. That was a first use case. But in the end, we foresee a lot of more state which can be maintained and detected in the system and provided towards all the other applications. And in this case, in this first use case, we built a system that every gateway is sending every X time just a message, I'm alive. That's a really easy mechanism, just a heartbeat message coming in to detect whether or not a system is online or offline. And this makes really sense because a gateway can be for hundreds of reasons online or offline. But if you can only detect if it is fully working, if there is data flowing from the gateway towards the cloud. So that needs to be initiated from the gateway every time and it needs to be constant. And based on that, you can do analysis and get really valuable data. And I will show a little bit about the value we get out of this one heartbeat message a little bit later in the presentation. So these gateways are sending heartbeats every now and then and on a frequent interval. And when no heartbeats are coming in, of course, taking into account that you could miss some heartbeats, then the state of the gateway will change, and then we will send out a notification, a push notification, so that the applications are actively notified about the state change, so that they can react on that and that they can present that also to the users, and that the users can, for example, get a notification on their mobile phones or in their mailboxes via the notification center that their device is offline and that they need to look into it. But there's way more information we can get out of this, but I'll dive into that a little bit later. So the requirements are basically on a very high level. We need to change the state from active to inactive or from inactive to active when there are heartbeats arrived or not any heartbeats arrived anymore after a certain timeout. Another one, it needs at this moment to support a concurrently processing of data of hundreds of devices who are constantly pushing the data towards the cloud. but it needs to grow to a huge number of additional state also, where the number we had in mind was that it should be able to scale up to a potential of millions of concurrent state changes at the same time. So that was something we needed to take also into account and in our minds. And the state needed to be persistent, because we couldn't get that state back again from the gateway. It needed to be there, and we also wanted to look back into the history of that state, because based on the history of the state, you can also get valuable patterns about different behavior of gateway, and you can correlate that to the environment, for example. So you also need to store that information so that you basically can have a timeline of your gateway and the behavior of your gateway in this case. So all the made the actor model, and we basically said yes, it's approved for the actor model. And the main reason for that is the processing, the parallel processing of this data, because every actor can in parallel process data while still maintaining a correct state for that one singular device. And that's very hard to implement if you want to implement that yourself in just during normal programming when you're not using an actor model. Just like Marco already mentioned, within Priva, we already have some use cases where we used audience in the past, and also our team also already had experience with the actor model, but that was a service fabric actor model. So we actually knew how that was working. We have a big system running on that also right now, but we were also evaluating to looking at Akka.net, because that was also being used at different places in Priva, and it's always good to standardize on a certain technology, so that you also have more people in the company who are using the same technology, that you can learn from each other, but also it's good to evaluate what is the best framework for the job you have. And in this case, we found out that we needed to choose Akka.net over Service Fabric, and there were a few reasons for that. One of the reasons was that, as far as we knew, Service Fabric is only request response. So that means that when you call an actor, you always need to wait for the response of that actor. And that's a big difference with Akka.net. And that's one of the main reasons to choose for Akka.net, because in Akka.net, you have the ask way of sending something to an actor and waiting for a response from the actor. But in the end, even that ask method is also underwater a message-based communication to that actor. And by default, the way to communicate with an actor in Akka.net is using a tell. So that's completely asynchronous. And we couldn't find an easy way to do that without working around the complete Service Fabric philosophy to do that with their actor model implementation. Although it has a lot of benefits and good stuff also, but this was the main reason for us that we needed to choose Akka.net, because we want to be highly asynchronous. Also, if you have an actor which is sending a message to another actor and then sending a message to another actor again, we've been in situations with Service Fabric where we created a circular loop, and that the whole system was in a deadlock situation, basically. Of course, you can prevent that also in your programming, and you need to look at those patterns. But with Akka.net, you are not that fast hitting those limits there, because by nature it is message-based. And this indeed helped us, especially because we also wanted to do a van out of the messages. We have one message coming in, and that needs to go to a bunch of other actors. And in Service Fabric, that actor which was dispatching those incoming messages towards all the actors was blocked until all the actors were completed with processing that message. And that is way easier to do in Akka.net in our experience. Another one was also the developer velocity, because in Service Fabric, the actor model implementation is really tied with the hosting of that actor model. The Service Fabric application, you need to run that on the Service Fabric runtime, and that comes with a Service Fabric cluster. So if you want to start those clusters, those actors locally on your system, you need to deploy them locally to a local Service Fabric cluster. And that adds up in the developer velocity of, in your normal developer speed and in your way of working, because you need to do additional steps. It is all automated in Visual Studio, that's true. But we found that with Akka.net, it's just not that tight coupled with the infrastructure it runs on. I need to rephrase that actually, because it's completely not tied with the infrastructure on which it runs. It's just normal .NET code, and wherever you can run .NET code, you can use Akka.net. So that was a big advantage also for us. Yeah, I also have it in the slide right here. Local debugging forces you to run a local cluster, deploy to it, and debug while it's running in that local cluster. With Akka.net, you just press F5 and your .NET application starts up, and you also have your Akka system, actor system running. You can also use some tooling to create some local clusters to mimic also the cluster behavior also locally. It's also possible. And for that, of course, you need to do some additional work, but out of the box, it works easier, and there's a less of steps which need to be taken for the developer to start up the Akka.net actor system. And another one which we found over the last years was also the community. For Service Fabric, it is sometimes really hard to find solutions for the problems. And my analysis of that is because Service Fabric is an internal internal system from Microsoft, which they use in a lot of the Azure services, which is the backbone of a lot of Azure. So I'm not arguing that it's not good, but out in the open, in the community, it's really hard to find when you have an issue, somebody else who also had that issue before, or somebody who could help you with that step, or if you have a question, where do you need to ask it? Stack Overflow is there, and a lot of people are reacting on that, but it's different with Akka.net. My experience with the Akka.net community is that that when you have an issue or a question, you can ask it on the Discord channel, or you file a GitHub issue for it, and within a reasonable amount of time, you always get a reaction from somebody, or from the team, from Aaron, of Gregorius, or somebody else reacting to it. That feels far more better than Service Fabric. And also, there's a lot of plugins around Akka.net which is having a broader ecosystem than with Service Fabric. Service Fabric is really good at actors and hosting it on a specific infrastructure, and it does that really well, also with the reliability and all that kind of stuff. But with Akka.net, you can integrate with a lot of more services, and you can deploy it on a lot of more places. And also, one example, we wanted to have a native integration also with Event Hubs, Azure Event Hubs in our system. For Akka.net, we could find a lot of potential ways to do that and hook it up with the Akka system. And for Server Fabric, we actually couldn't find a good solution to do that in the community on the internet. So that gives a little bit about the difference which we experienced. Yeah, Akka.net. It really was a nice fit for the requirements. So I'll now dive a bit into what parts of Akka.net we have been using. Because we wanted, based on incoming messages, we wanted to flip our state based on whether or not we are missing heartbeats. We started with using receive timeout, and the receive timeout is a method which you can use on an actor, that you get a message in your actor when there is a certain amount that there is no message in that actor received anymore. And that's really nice for killing actors which are inactive, for example, after a certain amount of time. So we thought, well, we can use that mechanism for flipping the state when there are missing heartbeats. And then we made a mistake. And that's not about Akka.net, but that is about us, because we were seeing that sometimes actors were not killed and the state was not flipped after we missed a few heartbeats. And that was because that same actor which was processing those heartbeats was also returning the state of that gateway. So during our testing period, we saw that certain actors, but not all actors, sometimes didn't flip the state correctly. So we thought, yeah, what's happening out there? And after some chatting, also with Aaron, we found out that we made a mistake, and that it was because we were also requesting the state to see whether or not the state was flipping. So we changed that a little bit. So we are now using IBET timers. That's a really nice interface and an abstraction around the scheduler, which is there in Akka.net. And we are now just checking every timeout period if we still have had heartbeats. And based on that, we are flipping the state right now. That works really well. I need to say that. I already talked about state. We have built state machines. We are not using the finite state machine of Akka.net, but we just built a state machine ourselves with become methods, where we change the behavior of the actor based on the current state of the actor. We use Akka persistence, and we use that to persist the state. I already thought that we wanted to build up some baseline also to be able to see some history also in the future. So we use Akka persistence for that. Akka persistence Azure to be more specific. We use Akka cluster sharding because we have too many actors which can be handled by one node, by one pod, and I will talk about where we deploy it in a minute. So we spread the load across a few different nodes, and we are also sharding that all those actors across all those different nodes. Besides that, we also make use of Akka.Hosting. And that is working really well, because right now at this moment we don't need to write any HOCON anymore. We can do it just like we are used to hooking up our ASP.NET applications. We are now also hooking up the actor system, and that works really well. We've used a few of the betas there, and we also use that in production right now, and yeah, it just works. But of course, there were also some challenges because our team was not that familiar with Akka.net. I had previous experience also with Akka.net, but the rest of the team didn't have it. So they experienced that there was quite some learning curve, because the difference with Service Fabric is that it is not that predefined. Service Fabric is really strict in the way you need to do stuff. It is you need to do it in way A, and otherwise it just won't work, and you only have way A. That's basically it. But in Akka.net you have a lot of choices to which you can make, and that makes it really powerful and flexible. But we need to say that it will have a little bit of a learning curve, but once you have gone through that learning curve, you also see that things fall into their place really quickly. But yeah, it's good to know that there is some learning curve, but there is a lot of documentation out there, and once you know the options, or you know a part of the options, let's say it that way, because we don't pretend to know all the options. But once you know more than enough what you need to run, it works really good. We are running it in container apps, and that was also one of the challenges we had in the beginning. We really wanted to use containers for that, but we didn't want to use Kubernetes at this moment in time. So we looked into hosting it there. We started with just one pod, just the easy way, without any communication between all the different containers. And luckily, also there was a new NuGet package and a new way of doing discovery, also created by the Akka.net team. That was Akka Discovery Azure, and that works. It works good, perfectly. Until now, it's a beta package, but we use it a few months right now in production, and before that, also sometime on our testing environments, and that just works really good. That will discover which nodes are running there, and it will. It makes sure that the cluster is forming correctly without having the need to use Lighthouse or some seed node pattern, because in container apps you don't have any static IPs. You cannot know upfront which nodes are always there and which can act as a seed node, for example. And Akka Discovery really helps with that, and it's good to know that Akka Discovery Azure that works with web apps, but also really good with container apps. Another one was health checks. There are a lot of health checks out there in the field, but for Akka.net, there were indeed some health checks, but we needed to take some steps to hook that also up, and to make sure that once the Akka system, the actor system, is not working anymore in one pod for whatever reason, for the features we were using, that it also recycled the pod, killed the pod, and restarted it, so that it really it adds it again to the cluster. It needed to have a little bit of custom code for us to calling the Akka.HealthCheck probes, and we implemented and wrapped that around an iHealthCheck to hook it up also in the ASP.NET HealthChecks mechanism, which is the default mechanism in ASP.NET applications. And we managed to do that. That was really nice. Akka.HealthChecks was a package which is out there for a really long time. And we found out that there was one thing which was not working out of the box. That was the persistence liveness check. There was a bug in it that because if you have multiple nodes, this persistence liveness check wants to write the state of a persistent actor to the state. and it didn't use a unique ID on the different nodes in the cluster. So we worked around that by making it a singleton in the cluster, but I also saw that it is fixed also right now in the Akka.HealthCheck package. So it's really nice. We didn't upgrade to that NuGet package yet, but we saw that flying by a few weeks ago. So that's definitely on the backlog.
Wessel's being modest here. He basically wrote the first pass of all the HealthCheck integrations, so it ties into the ASP.NET HealthCheck system. Gregorius and our team might have kind of polished it all, but that was originally sort of your design and your code, I might add. But yeah, by the time this recording airs on the 18th, Akka.HealthChecks will be a 1.0 by that point. Gregorius is actually working on writing the documentation for it today.
Okay. Oh, that's good to hear.
Yep.
Yeah, indeed. Yeah. Yeah, indeed. We did hooked it up in the HealthChecks indeed, and actually it was not really me. It was a colleague of mine, but I created only the pull request for it.
Oh, okay.
So that the credits go to him.
Well, we appreciate you guys contributing nonetheless.
Yeah. It was Lawrence who made that implementation. So. And indeed, I was also mentioning, because I saw that also Gregorius did the hooking up to Akka.Hosting. So I also wanted to mention that because that's also really nice. We've not been using that in real life yet, but that once the package is there, and I haven't checked if this is also released already, but when it's released, we are definitely going to use that. Okay. We are using container apps, and container apps is basically an opinionated set of running of an opinionated set of principles and tools to run microservices and containers, on Kubernetes without having the load to run Kubernetes yourself. And there is indeed a difference with Kubernetes. So, for example, that you have less control over your containers. What we found out is that during development, we missed the ability to, for example, kill and destroy a pod, to mimic the behavior of that something goes wrong, and even that when there's no pod left, that the cluster is still forming again. So we needed to implement some logic in our container itself to do the killing for those kind of tests. So that's something to be aware of, that because it's an opinionated set of principles, it gives you less maintenance, but also less control. So that's something to be aware of, and what we found out what a challenge was. And at the moment of developing this service, there was also not the support for zero downtime deployments. So that was also an issue in our actor model, because we wanted to have zero downtime. We wanted to have a way to seamlessly upgrade the cluster without having one cluster still in the starting up phase, and the other cluster already being killed, because that was at that moment the case. So we built some scripting around that to do some manual stuff on that. But luckily, Microsoft has fixed that in container apps. And right now you have zero downtime deployment also out of the box. So that's really good. And what also a challenge was for us was because container apps is, it is kind of new. It is there for some time already, but it is still new. And the versions of all the tools which are used there are, of course, lagging a little bit behind. But in our case, we faced some bugs in different components, especially like CADA and DEPA. And that lagging behind of versions that didn't help us. So sometimes we needed to step away from DEPA, for example, to build it natively in our ASP.NET application. I will show that, tell about that example in a minute. Kada. Kada is a Kubernetes event-driven scale framework, basically. And based on with Kada, you can scale on a lot of metrics. It is you can scale on any Prometheus metric, but you can also scale on a lot of metrics which are provided by the cloud platform you're running on. It has scalers for a lot of Azure components, service bus, event hubs, storage queues, CPU, of course, memory, but that's not always the best metric to scale on. But also from AWS or some other Nginx metrics, for example, like the number of HTTP requests. And based on that, you can scale your pods. And this is really helping because natively in Kubernetes, you need to do a lot of stuff to make that happen, to scale on those custom metrics, because those are not metrics which you can use in the horizontal pod autoscaler from Kubernetes. And that is where Kada comes in. So if you are looking for advanced scaling based on some metric, you need to dive into Kada if you're running on Kubernetes, or if you're using container apps, then you get it out of the box and installed. But we wanted to use no connection strings, but Kada right now doesn't support managed identities in Kubernetes container apps. So this was a bit of a pity for us. So I also wanted to share some challenges about container apps and Kada. So this was also one of the things we faced. We've seen that they are planning to add that support to it, but I don't know from the top of my head what the planning for that is. But it's at least good to know that we are not aware of a way to use the managed identity of a container app in the Kada autoscaler. So we needed to hook up some connection strings for that. And the nice thing is that the Kada autoscaler and the scaling of container apps in general works really nice together with the Akka.net discovery, which I already mentioned. So when it scales up, it sometimes in our case scales up from by a few nodes at a time, and we don't see that in the performance metrics of our servers. So that is really good, and also good to see that Akka.net discovery then picks it up and that it scales up, and then the cluster gets a few nodes added to it. Then the shard is going to be distributed across the cluster according to the sharding configuration that works really seamless and nice out of the box. And of course, because it doesn't have a connection to it, but it's good to see that also working in practice, because the theory is not always how it is in practice. Besides that, we also use Dapper, and Dapper is basically a set of building blocks which you can use out of the box in container apps. And with that building blocks, you can abstract away a lot of common functionality from your service, from your container app in this case. You can also use it on Kubernetes, but we've used container apps for this. And in Dapper, you have a lot of building blocks. I won't go into details about it. You can find the information on the internet. But we were using, I need to say that, some bindings, some input and output bindings. One thing to mention also is Dapper also has a building block for actors, and that actor model which they are using is heavily based on the Service Fabric actor model. I don't have any experience with it, but I know that has its basis in the Service Fabric actor model. So that's just for your information, also in relation with our choices we made. So that's the reason why we didn't spend any time on that, on looking into that. But in Dapper, we did use the service bus binding, and we wanted to use that because our heartbeat messages were coming from an IoT hub, and that IoT hub dispatches it to a service bus, and then we wanted to process those heartbeats. But the IoT hub, no, I need to go one step back. A service bus message has certain properties, and it has a body. In Dapper, in the service bus binding, you could not get those properties. And in those properties was all the information on which we could identify the heartbeat message. For example, the gateway identifier. That is there natively out of the box coming from the IoT hub. And we didn't want to add that also to the payload. So sadly, we couldn't use that service bus binding. At this moment, they fixed that bug. There is a new release, 1.9, Dapper 1.9. I think it is right now also released to container apps by this time. But yeah, we see that the Dapper is it's a nice set of building blocks, and it has a high potential, but you need to be aware that it is in a really early stage. It is used by a lot of customers, but if you need to use a not so mainstream functionality of some binding, then you might run into a case like we did, that you just hit some limits. But that's with every building block. I need to say that because we've hit the same limits also with Azure Functions and also with other abstractions on top of native implementations. So that's just good to know that, that's just how building blocks work. They cannot cover 100%. They cover a certain majority of the functionality. And besides that, we were using the event hub's input and output binding. Eventually, we ended up with this deployment. Basically, we have a managed environment that is our cluster, basically. And in that cluster, we have at this moment 2 components. We have an adapter for the heartbeats, which are coming in from an event hub in our case at this moment. I just mentioned service bus, but we have changed it to event hubs later. And we are scaling that heartbeat adapter with KDA based on the number of active messages, based on the unread messages in the stream. I didn't replace that text yet correctly in this picture, but in here it is correctly, because in here we are adapting this heartbeat message to a message which our ASP.NET cluster understands, because we wanted to also add more sources of state in the future. And with this architecture and with this decoupling, we can easily add that because this cluster and that state management is abstracted away from the adapting towards the outside world and the incoming of data. And in the end, when there is a state change in our core system, we dispatch that via event grid, because it's just an event which has happened. So some application can react to it. There's a lot of technology, but of course, technology, as I already said at the beginning, needs to bring value. And for that, I also wanted to show some graphs which the value of all those technology, which I have spoken a little bit about, is bringing for us and also for our customers, but also for our support department who are helping and reacting to issues at the customer side. Because based on this, we can see over a certain period of time how many gateways are changing the state. on a general level. This is just a random screenshot of some period. You can see that there are gateways which are coming active, which are becoming inactive, which are having an unknown state. That's also one of the edge cases in which there is no state at all for a gateway. That's also something to dive into. So these graphs are really giving value. And this is also all these graphs are based on only one heartbeat sent every now and then from a gateway. Another one is we can, for example, detect which gateways are flaky, which are some periods online, then offline, and also you can basically directly see which gateways are having, for example, issues. You can easily detect that based on this. And you can also see, and that's of course also a nice use case, which gateways are offline in a certain period of time, so that you can also proactively notify customers. They already get proactively a notification sent via the notification center, but you can also dive into that. And when a customer calls you for help, you can easily see, yes, indeed, we also see it in our systems. And you can, of course, also dive into the details of a specific gateway. And in this case, you can see that there was a flaky gateway. I just zoomed in a flaky gateway, and you clearly see a pattern here. You see a pattern that this gateway is every 15 minutes offline for a few minutes. So could be a few reasons for it, but it's at least noticeable that this gateway has this pattern. And then at 15:15, it stays online. So what has happened there? I don't know. I didn't dive into this case. Could be that there was a bandwidth issue, that the gateway couldn't send the heartbeats during that time. But if it couldn't send the heartbeats during that time, it also couldn't send other data, because the heartbeat is just a few bytes which are sent across the wire. But at least you have some timestamps and some data to dive into, and also you can easily recognize those patterns. And if you add this graph to it, you can see that heartbeats didn't arrive our system for some reason. But you can also see there is a white line there. In here, there is a white line. And this white line says that it didn't receive in a 2-minute time frame 2 heartbeats, but 3 heartbeats. So that means that some heartbeats were piling up, for example. So that could also give some information. And there's way more information we can add, we can extract from this, and that only by using some technology like an Akka system to concurrently process this data, because there's a lot of data coming in from all those thousands of gateways, which is being concurrently processed and stored in these systems, and which can easily be retrieved, as you can see in these graphs. Then what is more of Akka.net in Priva? Currently, we have, just like Mark already said in the beginning, we have modules on the edge gateway, on the new version of the gateway, which is using Akka.net. In our cloud, we are using it in, for example, the system state servers. Akka.net is already also used in some simulators of the devices which are running behind the gateway. So for our testing systems there, we also, there are some simulators where Akka.net is also used to simulate data. And in our alarm and notification handling system, there is also currently Akka.net also being used in production scenarios, because that can also be highly concurrent, that there are a lot of alarms can come in. That depends really on the situation. It doesn't have to be bad that an alarm is coming in. And there are also more things planned also for the future, like for the next generation of controllers. We are looking for the commissioning of that. There it is being looked into, also using Akka.net for that. And just like Mark already said, we're also looking at our real-time data platform to migrate there from Service Fabric to Akka.net to fully standardize on Akka.net. That were the things which I wanted to share with you, and there might be some questions.
Yeah, absolutely. Well, Marco and Wessel, thank you very much. That was very thorough, and I appreciate it. And I took about 2 pages worth of notes here while you were talking. So I wanted to ask a couple of questions, and I'm glad I saved my questions till the end because some of the ones I wrote down early you answered during the course of
Okay.
your presentation. But I did have a couple of key questions. So first, in terms of, you mentioned that it was basically the parallel volume of heartbeats and data coming from devices that were running on premise to their customers that kind of drove the need for the actor model in the first place. You mentioned the volume and just the sheer degree of concurrency is sort of the big factor there. I also wanted to ask about the latencies involved in processing those messages in terms of do you have any sort of like real-time processing requirement for some of these? Like I know you have the alarm and notification handling, which sounds like something that might have it, but I just wanted to ask if there was also that kind of facet to it as well.
You want to answer that, or Wessel, or shall I?
You may go ahead. Yeah.
Yeah. So for the real-time data, the requirement really is to get the real-time values onto the screens that customers are seeing under a second.
Okay.
So that's
So
really
that's
fast.
that. Sorry, Marco, go ahead.
Yeah, so it's really fast. So that's why when we have a lot of online users concurrently using the system, we have a lot of information going through it, and that's where the concurrency and scalability really comes into play. And that's where the actual shines, and it gives us this performance.
Absolutely. I mentioned in our clustering course when we teach that, it's like some of the requirements that are going to typically drive adoption of like Akka.Cluster specifically, or it's usually going to be the combination of a low latency processing requirement plus typically the need to be highly available. So the ability to keep up with demand and the ability to tolerate failures as well, right? So it's usually the combination of those two that kind of drive the need for that. So that makes perfect sense to me. And then you mentioned the volume of data that you see right now. So there's thousands of devices inside. That's what I saw on your slide. But you might need to grow to be able to support millions of concurrent state changes. Is that millions of messages per second coming in from all the gateways into your cloud, or is that like a per tenant number?
No, it is more. It depends a little bit because it's also PubSub based. Right now, our real-time data platform is handling those number of messages. I think it is right now not on a second base, but it is handling that. Now, I can say that from top of my head. I don't have the numbers in my head, but to be it's good to know that one gateway can be connected to a few. I think it is right now. How many controllers, Marco?
Oh, it varies. It depends. So if you look at horticulture, they have less controllers. Building, the bigger the building, the more controllers. So it can vary between 30 to 100 to for a new system, maybe 500 controllers. So there's a lot of devices underneath it running control applications. And underneath that, you still have your field devices, so the temperature sensors and those kinds of equipment. So there's a lot of equipment that can go into a site.
So indeed, so one gateway can easily be connected to 100,000 of sensors.
Oh, wow. Got it.
Yeah.
And then
and
ahead,
if you look
Marco.
at the state service and the amount of messages is just calculation. Right now, let's say we have about 500 or 5,000 connected sites. We will double that next year. double that again next year. And if each one of those is sending a message every 5 seconds, so you can kind of do the math on how much data is coming in only for this service. And that's not really even talking about values and those kinds of figures.
No.
So yeah, that's definitely a big data problem, to say the least.
Exactly. Yeah.
This leads me to my next question that I had, which is so architecturally, so your cloud services, are they all hosted in one data center currently? Do you have plans to do multi-data center where you might have, let's say, a Chinese basically site and maybe a South American one and a European site and so forth?
Yeah, so right now it's all hosted in Western Europe, but we're definitely looking at expanding that. Now, China is a story on its own. I'm not quite sure if we're going there. Those are other issues, but yeah, we are looking to expand that because we have a lot of customers in Canada, for example. So looking to provide the same requirements, saying under the second, the values. So we want to move stuff also to those kinds of areas. Absolutely.
Gotcha. Makes sense. And then let's see, a couple of other questions I had on here. Okay, architecturally, your deployment diagram that I saw you have. So my understanding is the way the system's built is that your gateway devices all connect to your IoT hub applications. So I assume that's using like MQTT or something like that under the covers. And then does your IoT hub application in Azure, that writes basically all the heartbeat messages into Azure event hubs, and that's what's read ultimately by Akka.Cluster. Is that right?
Yeah, that's right indeed. Yeah.
Okay, perfect. And so I take it then the way your cluster's built is that you have a number of different readers that are using maybe the Akka Streams connector for Event Hub or something that are basically just kind of advancing through the stream and acknowledging those messages as they get processed. Is that kind of how you ended up implementing that connection to event hubs?
No, in the end, not. We have been doing that, but we must say that we are not that familiar with Akka Streams.
Okay.
So it was for us kind of, yeah.
Too much of a black box?
Black box. Yeah, I was also thinking about the word black box, about how to implement that very good. And we had experience with just wiring up a hosted service in ASP.NET and using an event processor in there. So in the end, we ended up with doing that just to the Akka.NET cluster.
No worries. That's we use the Akka Streams.Kafka adapter for Event Hub ourselves in one of our applications. We're not dealing with. We use it for dispatching transactional email notifications on SDK bin, which is like we probably do as much volume through there in like 4 years as you do in about 2 milliseconds on your platform. It's not not very high volume at all, but it did need to be highly consistent and no duplicates and no lost messages. That was sort of our requirement. Oh, cool. I was just kind of curious about that. Then let's see. I think, do I have any more questions on here? Let's see. I guess the last question I had was about CADA support right now. So the metrics that you produce to go ahead and do auto scaling right now, you mentioned that you're using custom metrics to go ahead and drive some of that, or what are examples of some of those that you might use?
Now, we currently use two metrics. One is the number of unread messages in the event hub. So it checks the checkpointing on the storage, and then matches that against the latest offset, which is there in the stream. And if there's a more offset greater than X, then we're going to scale. And of course, you can only scale to the number of partitions you have on your event hub. Otherwise, you're not consistent anymore.
Mm-hmm.
So that is just the default scaler of CADA, which is there, and the other one is that we are scaling on the CPU metric and on the memory metric, because we use actors which are running in memory. We also need to make sure that we have enough memory, so that once the memory is hitting a certain level, then we're also going to scale up. But we never hit that one yet.
Wow, that's good.
It's mainly about it's mainly about indeed the number of unread messages in the event app, because that can very quickly be a lot of messages being added, and after that it can be a little bit more quiet. That's possible.
Yeah, that sounds like a perfect use case for auto scaling there. Whereas that queue length gets longer, the latency is going to increase on terms of the heartbeat detection too, right? So makes perfect sense to just dial up the number of consumers when that backup starts to get detected. That sounds perfect.
And that was also why we needed to have zero downtime deployment, and also that we wanted to make sure that after the deployment, we really needed the health checks to be 100% sure that those nodes are being added to the cluster and that they are up and running before shutting down the old nodes. Because currently we have set the time frame to 3 minutes, but 3 minutes is very quickly gone if you have a deployment of a lot of nodes.
Yes.
So we don't want a deployment to trigger a lot of state changes towards our customers, because this is a critical component in our architecture, which might notify all customers if this one is behaving wrong.
Oh yeah. Yeah, I can see that every tenant at once gets lit up with false positives, right?
Indeed. Yeah.
And then every single building manager freaks out and sends your support team an email at the same time. Yeah.
Yes.
We've had this happen in the past. Yeah.
Yeah, that's not fun. That's not fun.
Makes a lot of sense why that'd be so important to go ahead and keep that going. Well, that's all the questions that I have overall. Gregorius, do you have any?
Not really, but it's totally gratifying to know that one of my babies actually being used in this scale, like especially discovery.azure.
Yeah, that project was Gregorius's brainchild from like front to basically start to finish. So yeah, we're very glad to know that someone's using it at scale and is very happy with how it works. That's about as an open source library author, that's about as good as you can hope for, right?
Mm-hmm.
Yeah, well, Marco and Wessel, thank you very much. This presentation was very, very informative. I'm sure our users are going to love it. And I'll go ahead and keep you both on. I'm just going to turn off the recording here. And if there's any questions from our audience when they see this live, maybe they'll leave them for you on the YouTube comments, and you can come and take a look at them later.
Sure,
right.
No problem.
All right. Well, that was our this month's show and tell presentation from Priva. I see Wessel's here in chat. Wessel, thank you again, and you and Marco both for putting together such a detailed and thorough presentation. I think this is the first one we've had with developers that were actually using clustering and sharding in production. So it's great that we've had a chance to expose some of our users to what that looks like in production as well. So that was really helpful. And I think at this rate, we'll probably go ahead and wrap up here. I just want to mention a couple things to look out for. First, we are still looking for some more show and tell speakers for February and March. So our next sort of upcoming community stand-up. So if you're interested in sharing your story about how you use Akka.net in a commercial project or at work or even in an academic project, please go ahead and let us know. We would love to hear from you. But otherwise, please don't forget to go ahead and like and subscribe so you can go and get more content from us, whether it's another community stand-up or some of our videos about .NET programming and Akka.net. We, of course, always appreciate your support there. And otherwise, thank you very much for your time and attention, everybody who attended today. We always really appreciate it. And we will catch you next month. So see you next time, and thank you again.